Okay, so now to answer this question, there's some things we really need to understand on the periodic table. Okay, this question is very simple. Okay, so let's read the question and understand something. So the question reads, the table below shows the elements in a period of a periodic table. So we have these elements. You can see that we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, so these elements, they've been drawn out of one of the periods on the periodic table. Okay, so if your periodic table is like this, something like this, so you have these horizontal and vertical lines. Okay, so these here, they are called periods, okay, which go horizontally. These are called periods. Then the ones which move vertically, they're called groups. Okay, that's one thing that you need to understand. Okay, so we have groups and periods there. Okay, so now for us to quickly answer these questions, I'll just pick one of the elements here. Okay, and the most common element which everyone knows is oxygen. So I'll get oxygen and try to learn something. Okay, so oxygen, you know that oxygen is atomic number 8. Okay, oxygen is atomic number 8. Then it has mass number 16. That is oxygen. Okay, so now what are these numbers telling us? So the atomic number is showing the number of protons and electrons. Mind you, the proton number and the electron number is equal. So oxygen has 8 protons, it also has 8 electrons. Okay, then this 16 is the mass number, and the mass number is the total number of protons and neutrons, okay, combined together. So we should have neutrons and protons. When we add that, that gives us the mass number. Now, the atomic number here, it is showing you the number of electrons. So, to draw the electronic structure of oxygen, you'll find that oxygen in its first shell, fulfilling the octet rule, okay, it has only 2 electrons. Okay, it has only 2 electrons. Okay, because the rule states that the first shell has the capability of only having a maximum number of electrons, which is 2. So it can only have a maximum number of 2 for it to be stable. Okay, then since there are 8 electrons, okay, which means we need another shell. Okay, so the other shell will have the last 6 electrons. So we can have our last 6 electrons like that. Okay, so now looking at this electronic structure of oxygen, the electronic configuration will be 2, 6. What do I mean? Which means in its first shell it is having 2 electrons, in its second shell it is having 6 electrons, and it is not a balanced shell. Okay, the last shell. Okay, because for it to be balanced, it should have 8 electrons. Okay, no wonder oxygen will bond with other elements like magnesium oxide, okay, for it to be stable. Okay, but that's also a story of another day. Okay, now since we have 2 electrons and 6 electrons in the outermost shell, these numbers are telling us something. Okay, always the number of electrons in the outermost shell is the group. Okay, so oxygen is in group 6. Okay, because the number of electrons in the outermost shell shows the group in which that element is. Okay, then the number of shells an element has shows the period. So the period of oxygen is 2. Okay, it is only having 2 shells. I'm not getting this 2, no, I'm looking at the number of shells. We had the first shell and the second shell. So oxygen is in period 2 but is in group 6 because it is having 6 electrons in its outermost shell. Okay, let's go back to the question now. Okay, now look at what is happening here. Okay, so since we've said oxygen is in group 6 and this qualifies everything, which means this is group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group O or group 8. Okay, that's the thing. Now, let's read the first question and see if we can answer this question. So, saying To which period of the periodic table do these elements belong? So these elements, they belong in period 2. Okay, period 2. Okay, if you can see all these elements, they will always have 2 shells. Okay, let me pick one at random. For example, if I get maybe boron is here. So boron is atomic number 1. So if we count, this is group 1, then group 2, group 3. Okay, or if we said oxygen is atomic number 8, which means this one is atomic number 7, atomic number 6, atomic number 5. So if we get boron now, if we do something with boron, so boron, we're saying it is atomic number 5, right? Number 5. Okay, then if we draw the electronic structure, which means in its first shell it will have 2, in its second shell it will have how many? 3. Okay, so it is only having 2 shells, and you can see that it is having how many? 1, 2, 3. So which means it is in group 3. If you go back to the to the table, we can see 1, 2, 3. That's where boron is. Okay, so all these elements here, they're in period 2. Why? Because they're having only 2 shells. Okay, all right. Then question B, they're saying what happens to the number of shells across the period shown above? So what happens, since we've already said that all these elements, they're having 2 shells, so what happens to the number of shells across the period? Nothing happens, because they're all having the same number of shells. So we say the number of shells remains the same. Okay, remains the same, as simple as that. Okay, so the number of shells remains the same. Okay, the number of shells remains the same. All these elements are only having 2 shells. Then the next question, they're saying answer the following questions using only the elements shown in the table above. Each element can be used more than once or not at all. Okay, now the first question, which 2 elements would form an ionic compound? This question is coming from bonding. Okay, so ionic compounds, these are compounds formed from ionic bonding. There are 3 types of bonding. Okay, there are 3 types of bonding. We have covalent bonding, ionic bonding, and metallic bonding. Okay, so these are the 3 types of bonding. Now what happens when we talk of ionic bonding? So ionic bonding, this is a type of bonding between metals and non-metals. Okay, ionic bonding, this is a type of bonding between metals and non-metals. So here my only issue here is to just find which one is a metal and a non-metal. When those 2 bond, they will form what we're calling an ionic compound. Okay, now how do you identify that this is a metal or this is a non-metal? Listen to this. Okay, so just know that, okay, just know that all metals, okay, I love this number 5 and do this. Okay, so the number of electrons above 5, the number of electrons above 5 in the outermost shell, those are non-metals. Okay, if an element is having more than 5 electrons in the outermost shell, which means it is a non-metal. Then less than 5 electrons in the outermost shell, those are metals. Okay, so if an element is having less than 5 electrons in its outermost shell, which means it is a metal. Look at oxygen. We were talking about oxygen here. We said that oxygen has about 6 electrons in its outermost shell, which is more than 5. So oxygen is a non-metal. If we talk of boron, boron has 3 electrons in its outermost shell, which is less than 5. So it is a metal. Okay, as simple as that. Okay, so here they're saying which 2 elements would form an ionic compound, which is between a metal and a non-metal. Okay, so you can see that here when we get oxygen, we bond it with boron. That is an ionic compound. Okay, or oxygen and beryllium, it is also an ionic compound. Oxygen and lithium, nitrogen and lithium, all those are ionic compound. Okay, so we can have lithium carbonate when we react lithium and carbon. Okay, we can have lithium nitrate when we combine lithium and nitrogen. We can have lithium oxide when we combine lithium and oxygen. So you can just say you pick one so long as it is a metal and a non-metal. So you just say lithium and oxygen. You pick any. Okay, lithium and oxygen, these are the two metals or the two elements rather which will form an ionic compound. Then the other question, numerator the same, which element has a valency of 3? So people mostly get confused when we talk of valency and valence. These are two different things. There's valency and valence. So valency, this is the number of electrons an element can gain or lose to be stable. That's valency, this one. Okay, valency, this is the number of electrons an element can gain or lose to be stable. For example, oxygen, for it to be stable in its outermost shell, for it to have 8 electrons in its outermost shell, it needs 2 electrons. So the valency, okay, the valency of oxygen is 2 because it needs 2 more electrons to be stable. Now, what is valence? Valence, this is the number of electrons in the outermost shell, same as the group. Okay, this is the number of electrons in the outermost shell. So the valence for oxygen, the valence now for oxygen is 6 because it is having 6 electrons in its outermost shell. So that's the difference between valency and valence. When we say valency, this is the number of electrons an element can gain or lose for it to be stable. Then valence, this is the number of electrons in the outermost shell. Let's go back to the question. The question is saying which element has a valency of 3? Which one will gain or lose 3 electrons? That's a question. Which one will gain or lose 3 electrons in its outermost shell? Because they're talking of valency. Okay, so if we go to oxygen, we said oxygen needs how many? Needs about 2. So oxygen is not qualifying. Let's go for fluorine. Since oxygen is atomic number 8, which means fluorine is atomic number what? 9. Okay, so if we look at the electronic configuration of fluorine, we say that is 2 electrons in the first shell. Okay, in the first shell it will have 2 electrons. Then in the next shell it will have how many? 7 electrons, right? Okay, so it will have 7 electrons. Okay, so if you look at when it is having 7 electrons, it only needs 1 more electron for it to be stable. Okay, so even that one doesn't qualify. You check for other elements. If you come to carbon, since oxygen is atomic number 8, nitrogen is atomic number 7, carbon is atomic number 6. Okay, so since carbon is atomic number 6, in its first shell it will have 2. In its next shell it will have how many? 4. Okay, so now how many does it need for it to be stable? For it to be 8, it needs 4 more. You get that? Okay, so even carbon doesn't qualify. This is how you check. Okay, what about nitrogen? Nitrogen is atomic number what? Atomic number 7. Okay, so in its first shell it will have 2. Okay, in its first shell it will have 2. Then in its next shell it will have how many? 5. Okay, so for it to be stable, for it to have 8 electrons in its outermost shell, it needs how many more? It needs 3 more. Okay, because 5 plus 3, that is now what? 8. So nitrogen qualifies. Okay, that is how you check. So you just say nitrogen. Nitrogen. Even for metals, you can check the one which will lose 3. Okay, that's how it is. Okay. Okay, now the last question. So the last question is saying which element has allotropes? Okay, allotropes. Now, what are allotropes? So allotropes, these are compounds made up of the same element but exist in different forms. Those are allotropes. Allotropes, these are compounds that are made up of the same element but they exist in different forms. Okay, so the most famous or the most known element which has allotropes is carbon. Okay, the most common one is carbon. Why am I saying carbon? Because if you look at graphite and diamond, both graphite and diamond, they're made up of carbon. Okay, so they're made up of carbon but they exist in different forms. They're having the same element but they exist in different forms and they have different properties. For example, diamond is shiny and doesn't conduct electricity, whilst graphite is not shiny but conducts electricity. Okay, so carbon is the element that contains allotropes. Apart from that, you have boron, nitrogen, and oxygen, but the most common one is carbon.